Okay, so we're going to pick back up with this example. You're given that the sine of u is 5/13, and angle u is between pi/2 and pi. You're going to be finding the sine of u/2, the cosine of u/2, and the tangent of u/2. All right. Angle u is between pi/2 and pi. So its sine is 5/13. That makes this a -12. Pythagorean theorem. Okay, if I take an angle and I cut it in half, and if I take this angle that's in the second quadrant and I cut it in half, where is that angle going to show up? So think of an angle in the second quadrant, say 120 degrees. If I cut it in half, I have 60 degrees. So the sine of u/2, or the cosine of u/2, or the tangent of u/2 would be found over here in the first quadrant. So that tells me when I use my square roots that I'm going to be using the square roots from the first quadrant. In other words, they're going to be positive square roots. So I'm going to go ahead and find the sine of u/2. I'm going to use the positive square root. And if I look at my formula sheet, it's 1 minus the cosine of u/2. And the cosine from my triangle is -12/13. So 1 plus 12/13 is 25/13. Just go ahead and use a calculator there. Divide by 2, it'd be 25/26. Take the square root. Rationalize, and you've got it. So again, how did I know to use the positive square root right here instead of the negative? It all started with where is u at? U is over here in the second quadrant. Any angle in that second quadrant that I cut in half, remember you're doing a half angle, would show up back here in the first quadrant. In the first quadrant, sine and cosine and tangent are all positive, so I'm going to be using the positive square root. Now I'm going to walk you through the cosine of u/2. According to my formula, it's 1 plus the cosine of u divided by 2, all under a radical. So 1, and then I go back to my triangle over here. The cosine's -12/13. So I'm adding a negative, divide by 2. That's 1/13 divided by 2, that's a 26th. I take the square root. And there's my cosine of u/2. For my tangent, I'm just going to ignore the formulas altogether, and I'm going to take my sine divided by my cosine. And I get 5. Okay, the final thing I want to share with you is how to solve an equation from this part of the lesson. So some of you guys that are going into calculus will appreciate this. And this is the final part of the lesson. All right, so we have a half angle identity, we have cosine, we have sine, it's just kind of a mess. So what you're going to do is you're going to replace sine of x/2 with its equivalent half angle. From here, we're going to separate our terms so that we can square both sides. When we square both sides, we remove the radical, and that plus or minus, when you square it, they're going to be positive, so we can just take it right off. All right, we're going to multiply both sides by 2. Let me put everything on the correct side here. So then I brought these over. We're going to factor okay, let's fix that. Cosine x is a half and -1. So x would be, and we're solving this equation, I didn't write this down, but we're solving it from 0 to 2 pi. So x would be pi, x would be pi over 3, and 5 pi over 3. Now anytime you square both sides of an equation, you have to check your answers. They don't always check, and so when we check our answers, you're going to go back to the original problem. So we're going to put pi in there first. Is that equal to 0? So that's 1 plus -1 equals 0. That's true. So pi is an answer. Then we're going to check pi over 3. Pi over 3 divided by 2 is pi over 6. Is that equal to 0? So we have 1/2. The cosine of pi over 3 is 1/2. That equals 1. That's not equal to 0. And then we check 5 pi over 3. Divided by 2. Does that equal 0? The sine of 5 pi over 6 is 1/2. Cosine of 5 pi over 3, let's see here, is 1/2. And that equals 1 again. So not equal to 0. So pi is your only answer. Now, when you see a problem like this in the homework, it's going to ask you to check yourself with a graphing calculator. So if you go to Desmos and you plug this in, or use a graphing calculator if you have one, you can see that your graph only touches the x-axis right here, and that is at pi. So you can see the one solution there. So they ask you to double check your solutions with a calculator, and so you can do that. Desmos is a good one to use, and that should conclude the last part of 5.5, or the second part of 5.5. We have one more part to do, and that's sum to product and product to sum formulas, and those are pretty easy to get a hold of. So we'll do that part next week. Have a good day.